Good morning, students. So today we are going to start a new subject, that is design and analysis of algorithm. This is one of the important subject which is very much required if you are appearing in any competitive exam or in your semester exam, as far as your computer science and engineering stream and also allied department, that means your artificial intelligence, machine learning, data science, cyber security, all these which are considered to be as the allied stream of computer science are concerned. So this particular subject is required very much strong concepts to answer whatever questions you will be given in the various type of examinations, be it your semester or any competitive examination, including GATE, NET, all those things. So generally, today, starting from today, we will be covering the important topics that are related to this particular subject. So all those topics are actually broadly classified into 5 modules, as you can see in the screen. These 5 modules or units. In each of these units, you will be learning basically the important concepts of the algorithms, design and analysis of algorithm. So, to be precise, Unit 1, generally in Unit 1, we will be covering the introductory concepts that will be required in all remaining 4 units, whatever you will be studying. So, to start with, we will be learning your characteristics of algorithm, analysis of the algorithm in terms of your asymptotic notations, and the complexities, the bounds within which the algorithmic complexity can be defined. That means your best case, average case, and worst case behavior. Then performance measure of the algorithms in terms of your time and space complexities. These are the main two parameters based on which we actually measure the performance of the algorithms. Then the analysis of various recursive algorithms through the method of substitution or recursive tree method. And then you will be learning the master's theorem. Actually, the master's theorem is the very much is this short form to determine your complexity of the algorithm. That means your space complexity or time complexity, uh, whatever you do in substitution method or recursive method. So that is whatever the stuffs you will be doing in the substitution method and the recursive tree method in the master's theorem, based on certain formulas, you will be able to solve those things, obviously for a specific form of your recursive functions. uh, with the help of your master's theorem, you will be able to solve these things. Then we shall learn about various algorithmic strategies which are actually required to solve different problems. That means which are actually your brute force algorithm, then greedy dynamic programming, backtracking, branch and bound, and all these things. So I will be covering each of these algorithmic strategies with several examples so that the concept is clearer to you. Then we will be coming the, so these are the two sections. So then we will be coming to section 3. In section 3, we shall start with in section 3 we shall start with your various graph and tree algorithms. So to be specific, we will be learning over here the depth first search is your DFS and BFS. I think this DFS and BFS you have already learned in your data structures. So we will be revisiting those algorithms which are actually considered to be as the graph traversal algorithms. Then your shortest path algorithms, and minimum spanning tree algorithms, topological sorting, network flow algorithm, and transitive closures. These are the things we will be learning. Along with that, we will be approaching towards, in section 4 and section 5, we will be approaching towards the advanced topics of the algorithm, so which are very much important. So these are the algorithms. We will see what are the algorithms which are tractable and intractable algorithms for the problems. Uh, and then computability classes, which involves the P, NP, NP hard, NP complete, all those things. And moving on, in the last unit, we will be covering the approximation algorithm, randomized algorithm, and the classes of problems which are beyond NP space, NPP space actually. So these are all these things. So we will be starting. So since this is our first class, we will be starting with unit 1. We'll be covering the basic introductory concepts which are required to analyze or to write the algorithm. Okay. So to start with, what is an algorithm? Now, the algorithm uh, is, can be defined as it is a step-by-step procedure, okay, to solve a computational problem. Computational problem can be your any program which you actually do. I think you are familiar of writing and executing the programs in the previous semesters using C, C++, etc. So for all those computational problems, that means which you actually execute by giving, and you provide certain inputs and you are getting certain outputs. For all those problems, you can have a corresponding algorithm. Okay. So the thing is, algorithm can be written just like your program can be written in step by step procedure. But then when you are writing the program, it is also be written in step by step procedure, and the objective for both algorithm and the program is to solve a particular problem which has been assigned to you. So then what is the real difference between the algorithm and the program? Now, if I think if you are aware of software development life cycle, so if you are not having the concept of software development life cycle, let me give you certain let me explain that software development life cycle. In short, we can write it as SDLC. So one minute. SDLC. Okay. In the this, why I am telling you, because in this SDLC, so algorithm, just now as I told you, the algorithm is a step by step procedure to solve a problem, and a program also you write step by step instructions, some sequential instructions you write to solve a problem. But then what is the real difference between the algorithms and uh, problem? So first difference, so in the SDLCs, for that you need to know a little bit of concepts from the SDLC. So this is the software development life cycle. Now, in this SDLC, you see, you have various phases, and to develop a particular software. That means if you need to develop a software from scratch, you need to go through all these subsequent phases. So to start with, first phase is planning, and requirement analysis. I will discuss in brief each of these phases so that you can have an idea about at which phase the algorithm can be written and at which phase the program can be. Then comes your design phase. Then and unit testing. Then comes integration and system testing. Then deployment. Last phase, maintenance. Okay. See, in order to develop a particular software, what happens? You need to have a proper planning. How many modules will be there, or how many functional units will be there in that particular software? What would be the operations for each of those functional unit or modules, and all this kind of things. So all these things are discussed in details in a project. There are senior manager, then comes the junior manager, then team lead and the developers. So all, they have a meeting, as well as you have the dedicated testing team, means who will be testing whatever the developer will be developing with by coding. Okay, so they will the testing team is responsible to test the exact functional, whether the functionality which is expected from that particular module is satisfying or not, satisfying the requirement or not. So all these things actually we plan in discuss the plan, the development team of the software, of a particular software, who's sit together and they plan among themselves how to design each of these module, each of these functional units that actually are comprises within the software which is required to be developed. Okay, and to develop each of these functional unit of or the modules in a software, you need to analyze what are the requirements. The requirements can be in terms of human resource, or it may be in terms of your hardware support, that you need to analyze first. Okay, so if you need to develop a particular, for example, if you need to develop a particular software, and this practice actually is followed in various industries as well. So if you need to develop this particular software, you first plan the senior manager and the senior test leads and senior developers, all those sit together and plan what will be the, how many functional units will be there in the software, and how each of those units will work, what should be the, how the workflow of the entire software will be. All these things are done, are planned actually in this planning phase. And once you are planning these things, then you uh, uh, analyze what are the requirements for this planning. So for example, if you want to develop a software using a certain platform, for example, you want to develop a software using Java, and if you see that your development team has no such team member who are actually expert in Java. So in that case, you it may be required to hire certain experts in Java, okay, who are actually the experts in Java. It is there may be the requirement to hire those kind of professional so that they can work uh, in that particular project. Similarly, if in order to develop a particular software, if you require some high-end configuration machines, which is not there with the team development team at the moment, then they may raise the requisition to purchase those kind of high-end configuration machines. So all these are actually done in the requirement analysis. So planning and requirement analysis is the one phase which actually initiate this software development life cycle of a software which is to be developed. So once this requirement analysis and planning and requirement analysis is over, there is a phase which is your design phase. So in the design phase, you need to design the each each functional unit of a software. Now, while designing each functional unit, generally we use algorithmic step, that means common English language which can be understandable to everyone. He or she may be from technical background or maybe non-technical background. The algorithmic steps are written in English like language. Generally we write algorithm for a particular software which is to be developed in the design phase of that particular software development life cycle of that particular software. Okay. So in this design phase, apart from this algorithm, there are many other thing which we actually design. We design the class diagram. We draw the class diagram, DFDs, all those things. But the algorithms, if it is required to for a particular functional unit, which is the integral part, which has been planned to be the an integral part of a software, to implement that or to develop that, we need to write the required algorithmic steps for that particular functional unit of the software. So that the generally, so we write generally the algorithms in the design phase. Next is your coding and unit testing. In the coding phase, so as you all know, whatever algorithmic steps we have designed, we have written, we in the design phase, those algorithmic steps are then converted to the to programs or the instructions of the programs, so that that algorithm is being implemented to develop that particular functional unit of a software. Now the coding can be done if you require the Java environment, then you have to hire, or if you are having the existing employee who are expertise in Java, so they will be coding the algorithmic steps in Java, and that will become a program for you. Or if there is a requirement of any other language, say Python or C, C++, all these things, then the programmer will be writing first. The programmer will be reading the algorithmic steps that are written in the design phase, and then understand it, and accordingly you will be writing the programs to implement that functional unit of a software. So after that, after writing that program, so he or she need to write the program correctly. So for that, once he will be once he is the programmer is developer is done with the coding, then he will be testing uh, certain test cases, so that whatever required, whatever is expected from that module, are all those things are performing, are all those things are executing properly or not. So that is your unit testing. We do this kind of unit testing in a part to module specific way. In a software there may be a multiple modules, so each module, if a development team is responsible to develop a particular module, then they will be performing the testing by themselves, so that whatever code they are writing, that should be correct. And once the testing from the development team is done, then they will be assigning that particular module, the executable file of that particular module, to the testing team. The testing team will be testing again by following the test cases. That would be very much rigid testing. And if there are any errors or any logical flaws in the code of the particular uh, programmer, they will be raising that issue as a bug and assigning the entire bug to the development team who were actually responsible to develop the software. So in this way, so this kind of thing happens, so that to write, so that the code can be updated and can be made as much error free as possible. So these are the done in the coding and unit testing. So in this design phase, we write in this design phase we write actually algorithms, algorithmic steps of the we write the algorithms of particular program, algorithm to which will perform a specific task. Okay. And in this coding and unit testing phase, the developers are responsible to write the programs which are actually the implementation of these algorithms. Okay. Then comes the integration and system testing. So once the modules are developed, then the modules are integrated. And during the process of integration, if any bugs arise, then the testing team will again raise that bug and assign that bug to the development team. The development team will again fix their code and make the code as much robust as possible by fixing the bug. And once the integration is done, then the system testing means the entire software as a whole is being tested by the testing team. And whatever, again, if there are any uncovered, if there are any bug that was not raised during the unit or integration testing and has occurred in their system testing, so the testing team will be responsible to raise that particular issue as a bug. And as usually the as usual your programmer team or the development team will be fixing those bugs. This process continues, and side by side, and we, by the contribution of both the development team and the testing team, the the programs actually are made as much error free as possible. Okay. And then after the software is being developed, it is being deployed in the client's end, and the maintenance is being provided till the time which has been done, which has been agreed upon by both the client and the service provider company, will be who are actually responsible to develop the software. These are the phases of the SDLC. Now, I have told you these phases of SDLC just only to give you an idea at what phase the algorithm is also a step by step instructions that we write for a particular problem to solve a particular problem, and the programs are also the step by step instructions which we write to solve the problem. But if you analyze in greater detail, you will see the algorithms are written in the design phase of a software development lifecycle, whereas the program is written in the coding and unit testing phase of a software development lifecycle. Okay. So this is one difference. So it is written in the this is written in your design phase, and it is written in the implementation phase, or the we can say this implementation phase as the coding as per the SDLC life cycle. We can also say this implementation phase as your coding and system testing, coding and unit testing. Okay, this is one phase. So this is the first step. The second difference is what? An algorithm, yes, an algorithm is related to a particular domain, should be written by expert who are actually having the knowledge of that domain. Okay, so on always whenever an algorithm is written, always a domain expert is responsible to write the algorithm, to make the algorithm robust. Okay, as an example, so if you all of you are actually well aware with a financial accounting software, that is your tally. So for that tally software or any accounting software like tally, if you want to develop an accounting software today, so for a person who is having the knowledge of accounting, he will only be able to write an effective algorithm for that particular software, because he should know how a accounting software works. So based on that, if he knows all these things, then he will be able to write the better algorithm or the more efficient algorithm. So what we can say in one liner, that an algorithm should always be written by the domain expert. Okay, whereas the program for that algorithm which has been written, the program which is actually written in the implementation or the coding and unit testing phase, the program is written by the programmer who is actually responsible for implementing the algorithm into that program. So the programmer, so while writing, the programmer also should have the knowledge of that particular domain. So if a programmer is implementing an algorithm written by a domain expert for an accounting software, so the programmer while implementation of that particular algorithm should also have the knowledge of that accounting software, so that he can also able to implement that algorithm effectively in programming statements in the form of program. So the programmer should have the knowledge of the language on by which he or she is writing the program, as well as the knowledge of the domain on which he is actually working upon, or he is actually intended to develop the software. Okay. Next, so this is the second difference. This was the first. Okay. Third, so as I have told you the earlier, that the algorithm can be written is usually written in English like language. It is written in generally written in English like language, because since this algorithm is written in design phase, so in the design phase you can have various technical as well as non-technical person who are actually involved in the design phase of a software development life cycle. So the algorithm is written in English or English like language, so that it is understandable by both technical and non-technical person. Okay, algorithm. But if you consider the programs, if you consider the program should be written by a technical person who is actually comfortable with the programming language, which is being used or which is expected to be used to implement that algorithm. So if while building or developing a software, if a person is required to implement an algorithm using Java, so the programmer should have the knowledge of Java to implement the English like algorithmic steps to instructions of Java. So the domain knowledge or the domain knowledge of a programmer should be the domain based on which the domain on which he is developing the software, as well as the domain of a programming language which is expected to be used to implement the steps of an algorithm. So this is the third difference between algorithm and the program. Okay. Then the fourth point, the algorithms are actually written in English like language, and they are actually the hardware and the operating system independent. So they does not, while writing an algorithm, you did not have to depend on the hardware or the operating system on which you are writing the algorithm. So algorithms are independent of hardware and operating system. Okay, so algorithm, in other words, the algorithm does not depend on any machine configuration or the OS that is installed in that machine. Okay, but in case of program, the program is dependent on the hardware as well as the operating system that is installed on that machine. This is the difference. And difference number 5 is, once the algorithm is written, it is analyzed, the analysis of the algorithm actually is done based on time and space complexities. Okay, so we will be learning in details in the subsequent, in my subsequent lecture, what how the first we will learn how to actually develop the time and space function of a particular algorithm, and then we will be analyzing those algorithms using those substitution method or that tree method, recursion tree method, or the master's theorem, that are the actually tools to analyze the time and space complexity of an algorithm. The analysis of the algorithm are done based on time and space complexity. Whereas for the program, once the program is written, it is tested using various input dataset, and it depends upon, it is tested based on various input dataset, and it is also we actually monitor how much memory the program is acquired. So the less amount of memory a program acquires, it would be considered to be more effective. So that is the memory management. Not the memory management, the memory utilization is also an important aspect as far as the testing of a program is concerned. This we will also see in the subsequent lectures. This is all in all the difference between algorithms and programs. Okay, now we shall start with another topic, that is your priori analysis and posteriori testing. Okay, so priori analysis. So what is a priori analysis? First of all, a priori analysis is actually done on the algorithms. Okay. And it study how the algorithm works in greater details. This is the main concept behind your priori analysis. So priori analysis are usually the studying the performance of an algorithm, in other words. And posteriori testing is done on programs which we analyze in terms of, as I told you just now, which we analyze in terms of execution time and how much memory it consumed. So execution time actually depends upon the input data set. If you if the more input, if your data set is size of the data is huge as an input, it will be taking more execution time compared to the smaller one. So two main concepts are these, priority analysis and posteriori testing. So priority analysis is the uh, starting of the performance of the algorithms in greater details, and the posteriori testing are the starting the performance of the program in terms of execution time and the memory consumption and the memory consumption. So this is actually first point. Second point is, this is the second point, priority analysis and for posteriori testing. Now the priority, since we know priority analysis is done on algorithm, therefore such analysis, since algorithm is itself hardware and software independent, and it is also the algorithm is also language independent, because no algorithm is used is written based on English like language. It does not, so a person does not have to be have does not require the knowledge of various programming language to write an algorithm. So for priority analysis also, the analysis which we perform on the algorithms are actually hardware and language independent. Okay. For the posterior testing, since it is done on programs, so therefore posterior testing is hardware and language dependent, because program itself is hardware and language. Okay. And three, it is your priority for priority and posteriori analysis and posteriori testing is that by doing the priority analysis of an algorithm, how we analyze an algorithm? We analyze the algorithm based on the time and space function, their corresponding time and space function, which we will see just as I told you. We will be first developing the time and space function, and then we will try to analyze it. So we actually analyze the priority analysis actually is done based on the time and space function of the algorithm. And by doing the posteriori testing, we determine the one is your execution time and memory consumption. These are the two things. Memory consumption in terms of byte, kilobyte, bits. So these are the three main difference between the priority analysis and posteriori testing. Okay. Now with this, we come into another topic, that is your characteristics of the, okay, characteristics of algorithm. Now, so there are in terms of characteristics, you see, for any algorithm we write, okay, you can have, so for that algorithm you can have either zero or at least either zero, or you have to give more inputs. That means either one or many inputs. So for any algorithm may or may not accept any. Okay. Input is one parameter which is considered as the characteristic of the algorithm. So an algorithm can consider or can accept either no input from the user or the multiple input. Okay. Okay. Now output. An algorithm must generate at least one. It must generate at least one output. Okay. Imagine, as for example, since you are all aware with at least C and C++, because you have done various programs in the previous semesters, now you imagine from that, you imagine a function which you have written in actually C or C++, which can accept a zero or more input and it will generate an output. You can also imagine. So, suppose a display function. You are writing a C function, that means a display function. A display function generally, if you are writing a display function, so 1 minute. So if you are writing a display function, the display function generally uses the if you are writing any display function, so a display function can be, you can have the void parameter list, or you can have any you can write any function which is taking the void parameter list. Void parameter list, that means you are taking accepting no input from the user. But whatever execution steps you will be writing within this particular function, that steps will ultimately generate at least one output. So otherwise, if it does not generate any output, how would be able to know whether your algorithm, whether your program is actually doing the what task it has been expected to? An algorithm should have it should accept either zero or no input, either zero or more input, and it will always generate one output. Okay. Otherwise, writing an algorithm which does not generate no output is meaningless. So you have to write an algorithm which generate at least one output. Now again, the definiteness. This is the third characteristic. What is the definiteness? Whatever statement we are writing in an algorithm, okay, that should be unambiguous. That means, what is unambiguous? So what is ambiguous? If you are writing a statement in an algorithm, and if that statement is having a dual meaning or multiple meaning, that statement will be regarded as a ambiguous. That means you you can interpret the internal meaning of that algorithm in one way. Another user who is studying the same algorithm for the implementation of that particular algorithm into program. So another user who is actually studying that algorithm will interpret the different meaning out from that particular same statement. Okay, so those kind of statement are said to be which is having the dual meaning or multiple meaning are said to be ambiguous. Unambiguous means the instruction should be clear and it should have the same single meaning. So everyone who will be studying that algorithm and for that particular algorithmic steps, they all will understand the same meaning out from those that particular algorithmic steps. So that is, you need to write an algorithm with all steps which are English like language in unambiguous manner. No statement should be ambiguous. All the statements should be ambiguous, unambiguous. Okay, that means they should have each of the statements which you are writing in an algorithm should have the clear and precise meaning so that it can be understandable, clearly understandable to the programmers who will be implementing that algorithm. Okay, that is your definiteness. Finiteness. What is the finiteness? The finiteness. So an algorithm it must terminate at some point. So it is not that you are writing an algorithm and it is writing such an algorithm that it is a never-ending process. Means it is go continuing for time and for time and time. Okay, that should not be the case. An algorithm should terminate after some finite step. Okay, that means the an algorithm should be finite. After some step, it should terminate. That means an algorithm. So there are certain programs contradict compared to this. You can consider another thing, that is there are certain programs, that is for example you say any database server or a web server which actually goes on running and running it continuously, it runs for continuously, it is going on running in the background. So an algorithm is unlike that. An algorithm should terminate after finite time. Okay, so that is the actually the finiteness. So an algorithm should be finite. That means an algorithm, it should have a finite number of steps and it should terminate after a finite number of steps. Effectiveness. What is the effectiveness? All the statements in the algorithm must be written to for certain purpose, to fulfill certain purpose. Okay, so it is not that we are writing any unnecessary statement in an algorithm which does not have any purpose to solve the problem for which we are actually designing the algorithm. So all the steps, all the algorithmic steps which we are writing in an algorithm, it should meet certain part. It should be written with certain purpose. Okay, that means the algorithmic step should be effective, whatever you shall. As an example, as a real life example, to understand clearly what is the characteristic of an algorithm, as we can say. So we consider, you can consider, you can go back to your class 12 days, 11, 12 days, where you are actually engaged in doing certain chemical experiments in your lab. So or in the first year you have done the chemical experiments in your lab. So where actually if you relate a particular chemical experiment, so that is a chemical experiment what you do actually, that again can be written in certain algorithmic steps. So you can relate with that experiment with the characteristic of algorithm. So I'm providing over here an example for related example on that matter, so that you can have a clear understanding on the characteristic of. So when you are performing a chemical experiment, so that this is what is basically an experiment. It may be a chemical experiment or the or the physics experiment which you can perform in the physics or chemistry lab. So an experiment is basically a procedure which has where actually each which is actually used to have the which is actually which actually have the above all these five properties which an algorithm also have. Because an algorithm, at the end of the day, an algorithm is also a step-by-step procedure to solve a problem. And the chemical experiment or the physical experiment is again a procedure. So the characteristic of an algorithm, whatever the characteristic of an algorithm you have studied, so similar kind of characteristic you can also observe for doing for such an experiment. For example, so while you are conducting a chemical experiment, so some what we do first. So some chemical are required first to start off with that particular experiment. We uh, require certain chemicals to start the experiment. So what are those chemicals? We can consider those chemicals as the input to the procedure which we actually follow in the entire experiment, entire chemical experiment. Okay, so those chemicals are consider can be considered to be as an input. Okay, so this is one property. Now the experiment which we perform, the chemical experiment that we perform, it produces an output. That means a result, means the outcome is generated from that chemical experiment. So that is actually your output. That is the second characteristic of an algorithm basically. Okay, now then again you see, once your experiment start, we what we do, we should only do some known step to continue with our experiment. So once we start our experiment, we should follow certain predefined steps or the known steps that are mentioned. We know the how to, we need to know, we should have a prior knowledge how to perform that experiment. So if you need that the chemicals to be boiled fast, and then the smokes that is generated from that experiment, then you need to collect that smoke, and then it should be cooled, and then you can get the resultant output from that chemical experiment. So you have to follow that thing, that procedure. So that procedure, so that means what, the you need to follow to certain known step to perform that chemical experiment. That is what, that is your definiteness, certain known step. So beyond that steps you will not be performing certain steps. So certain known step, and after, and after following these steps your experiment will end. That means all those steps which you are following are considered to be as the definite steps. So after a finite number of steps, which is predefined steps actually, which we will be for predefined steps which you need to follow, those predefined finite number of steps in order to make that chemical experiment a successful one. So that is, in other words, that is your definite. Okay, and then then you see the experiment. So after performing those steps, the experiment should stop. So it is not the fact that your experiment whatever you are doing, your experiment is going on and on, it is a never ending, and it is implying that the experiment, that chemical experiment, is a never ending process. That does not happen, because whenever you are starting a chemical experiment, after certain time of performing those steps, your a chemical experiment will stop. So that means whatever steps you are actually considering or following to perform that chemical experiment, those steps are regarded as the finite number of steps. That means the finiteness is there. It is the fourth characteristic of an algorithm. So this is also behaving like an is also, this chemical experiment is also having a characteristic similar to that of an algorithm. And the final step, that is your effectiveness, is what? So whenever you are performing an algorithm, and a chemical experiment, whatever steps you are following, those predefined steps, all those steps are to be performed, and each of those steps to have to make your experiment successful, because each of those steps contribute to certain specific tasks, to which eventually make your experiment successful. So that is the your effectiveness. You are not following any steps in the midst of the experiment which does not fulfill, or which does not contribute to that particular experiment. So now no unnecessary steps you are following in the experiment. So whatever steps you are following, all those steps contribute to the success of the experiment. So that is, in other words, the effectiveness. So all these five characteristics of an algorithm which you have studied can be related with, it can be related with any physics or chemical experiment which you have already done. So because those experiments are the procedure which you are following, this is, and the algorithm is also a procedure to solve a problem. Okay, so they are alike. So this actually concludes your characteristic of an algorithm. Okay, now this is the very important topic, that is how to write and analyze an algorithm. How to write and analyze an algorithm. Okay, so you see this algorithm, that is, it is just a, you all are aware with how to swap the values of two variables. You have already done that in your previous semester. So this algorithm is just the these algorithmic steps implies the swapping the values of the two variable using the third variable. This is the corresponding algorithm for that. So this is the syntax of writing the algorithm. So here you can notice, instead of, if you actually, for this particular algorithm, so if you want to write a code snippet for this particular algorithm, what would be your code snippets? For example, you are using C to implement this particular algorithm. So your code snippet will be what? Let me write the equivalent function of this. So you would be able to relate. So see, in this case, swap function, it is returning in nothing. So it's a void swap int a int int. Okay. Then instead of begin, you see this begin and end over here. This is your begin and this is your end. This means you begin means you are beginning an algorithmic block, and end is the end of an algorithmic block. So this can be replaced in the code section as the two opening and closing curly brackets. And within this, you can write these steps. These steps as so int I will be mentioning another variable, that is temp. So temp will be writing temp equal to a. This is one statement. A equal to b. This is another statement. And b equal to temp. This is another. If you execute these three statements, these values of a and b will be swapped. So you see over here, that this in the algorithmic step. So you see how to write an algorithm. So this is the algorithm. We are writing what algorithm? We are writing over here the what algorithm, and then the name of that algorithm is swap. We are writing it in the capital letter. We are following this particular syntax, and within that, within the brackets, these are the two parameters, which these two parameters are actually the inputs to the algorithm. Okay, a and b. Is a and b are the two inputs of the. So if you can relate, so what you can have zero or multiple input. So over here you are requiring two inputs for this particular algorithm. Same thing we are writing over here in the code. So since it is returning nothing, so void keyword, so void swap int a and int b. Now we begin. So curly braces opens int temp. Temp is the third variable, which we will be requiring to swap the value of the two variables. Is the third variable. Now you see the value of a is being assigned to this variable temp using this arrow mark. Okay. So whenever you will be writing this in the or coding, you will be replacing this arrow mark with the assignment. Okay, equal to assignment operator. Then b, value of b is again assigned to value of. Now value of b is assigned to value of a means a equal to b. That means value of b will be assigned to value of a, and the original value of a over here will be overwritten. But a copy of it is already being assigned to the variable temp. So that value of a is not lost. And then the temp, value of temp is assigned to variable. That means this temp, and how we are writing it in the program. So b equal to temp. That means the variable temp, which is having the value. That means the value of temp is actually the value of a, which was already being assigned from a to this variable. Now this value of temp is now being assigned to the value of b using this assignment. Now this is your corresponding algorithmic. This is your corresponding program. Okay, for this algorithm. So this is the way we write the algorithm. Okay. Now, and how, and this kind of algorithm we need to analyze using the time and space function. These are the, apart from the time and space function, there are various other criteria to analyze the algorithm, but these are two main criteria and which we generally use to analyze the algorithm, this time function and space function. Okay. Now, what are the criteria to analyze this algorithm? First, as I have told you, there are various other criteria apart from this time and space, but we generally concentrate on these two criteria only to analyze the algorithm. Okay. The time function. What is the time? So, what is this particular time function? So, these are these time and space function are the mathematical functions actually. Now, once we write an algorithm and analyze, I will tell you several, give you several example where actually we will learn how to write the time and space function of the algorithm. Okay, so what is a time function, time complexity or time function for an algorithm? So once we write an algorithm, we analyze how much time it takes and express it in terms of mathematics. As I told you, it's a mathematical function. So we express the amount of time required by an algorithm which we have written in mathematical format. That is your time function. In mathematical functions, that is your time function. And space function, how much memory it consumes, that algorithm consumes. And that we actually mention, express in terms of again a mathematical function which is generally known as the space function. So, but we have studied, also we have studied, it may be confusing to you since we have already studied before that an algorithm is actually hardware and operating software independent. So how can it consume the memory? See, actually an algorithm, whenever an algorithm is written, the objective behind that is that it should be implemented by an programmer in terms of program. Now, whenever an programmer is implementing an algorithm in terms of program, then it will consume memory. Now, the memory which is consumed by the corresponding program for a particular algorithm which has been developed, that memory, that amount of memory, that the amount of consumed memory can be expressed in algorithmic phase with a mathematical function, that is your space function. That means we can measure the upper bound or the lower bound of the consumption of the memory whenever we are implementing that algorithm into a program. And that lower bound and upper bound is being measured with the help of a mathematical function. Okay, is expressed by the help of a mathematical function. Same thing happens for time function as well, because whenever an algorithm is implemented in program, it would be taking certain execution time to generate the output. Now that execution time, whenever you are in the algorithmic phase, design phase of a software, and when you are developing the algorithm, that execution time, we can express that execution time. That means whenever it will be implemented to program, that particular execution time we can express in terms of a mathematical function which will be either which will give you an idea of upper bound, lower bound, or the average bound, a bound of that particular execution time. And that bound we actually we actually analyze those bounds with the help of a time function which is being expressed mathematically, and then it is being solved using certain techniques. That means you have the substitution method, you have the tree method, or the Nast's theorem that you will see subsequently. Okay, from this, so these two things are the very important aspects to analyze the algorithm criteria. The next criteria is the network consumption. So network nowadays, since nowadays most of the applications are developed which are actually the web based or the cloud based, if the algorithm is related to the transfer of data, then the network consumption become a vital criterion to analyze the algorithm. So network consumption is considered to be as another criterion to analyze the algorithm. The fourth criterion is the CPU register. So if you are developing an algorithm, so CPU register, how the CPU register is contributing over here. So if you are developing any algorithm for a device driver, for example, so then the utilization of for a device utilization of CPU register become very much important. So that actually utilization of the CPU register also plays a critical role to analyze such algorithms which are as far as your device drivers are concerned. So any algorithms related to the development of device drivers or related to device drivers should be analyzed in terms of your CPU registers, utilization or of the CPU registers. Okay. Now, so you will see this one by one. The first, the time analysis, which so among these four, these two, that is the time analysis and the space analysis, are the very much vital. And we generally use these two criteria to analyze an algorithm. Okay, now how we do these things? So let us again revisit that particular algorithm, that is your swapping the value of the two variables. This is the one of the simple algorithms which you can have. Now you see over here this algorithm swap AB. These are the two inputs which are which this algorithm swap accepts. Begin, temp. So you see each of these within this begin and end block, there are three statements. That is, value of A is being assigned to temp, value of B then assigned to A, and value of temp is assigned to B. Now each of these three statements required one unit of time. In algorithmic term, this one, okay, this one represents a constant time, a constant value. That means, for example, let me clarify one thing. So, for example, you are actually, if suppose there are 10 students who are actually executing this particular, implementing this particular algorithm in terms of program. Okay, and these 10 students are given the 10 PCs which are having the same configuration. Okay, now if now whenever they are executing implementing this particular algorithm, if this particular statement is taking 5 millisecond time to execute, then all other 9 machines or which are having the same configuration will be taking these 5 milliseconds of time. If this instruction is taking 2 milliseconds of time, then all other 9 machines will be taking the 2 milliseconds of time. If the third instruction is taking, suppose say 10 milliseconds of time by one machine out of those 10 machines, now all the remaining 9 machines will again be taking the 10 milliseconds of time, because the configuration of all those 10 machines are same. So you see this, the execution of this statement in all the 10 machines are constant, because no change in execution time is being observed over here. So 5 millisecond in one machine means 5 millisecond in the rest of the 9 machines. Over here 2 millisecond in one machine for this, for the execution of the second statement. This means that all the 9 machines will be requiring 2 milliseconds to execute this. That means it is taking constant time as far as you are keeping the configuration of the machine as fixed. That means it's a constant time. So it is a constant value or the constant time it is taking. So that means we express this in terms of since we are analyzing the time function of this particular algorithm. So it will be, so this statement will be taking 1 unit of time. Second unit, the second statement will be taking 1 unit of time, and third unit will be, statement will be taking 1 unit of time, because each of these 3 units are actually the constant time. Okay. So total Tn will be what? You add all these things. So Tn for this case, for this algorithm will be 3. That means this is the constant unit of time. 3 constant unit of. Okay. So Tn will be the a constant unit of. Now suppose, okay. Now suppose this is one vital thing. Suppose in this above experiment, in this above, not in this above algorithm actually, in this above algorithm, or in any in another algorithm, you are having a statement like this, is x equal to 5 into a plus 3 into b. So in that case we will also say this particular statement will be taking the constant unit of time, that means 1 unit of time. The constant value means it is represented as 1 unit of time in terms of time and space both. Okay, so it will be taking 1 unit of time, as we are not going into the, and this will be taking constant unit of time as far as, just remember this thing, as far as we are not going into the details of the machine language, equivalent machine language code, and analyze this statement. Because if you are going, once you are going, that is the beyond the scope of this particular subject. But just a brief thing I would like to say over here, that if for this particular statement, that is, say x equal to 5 into a plus 3 into b, in this case this multiplication, if we are going to the machine language, so it will taking the more machine cycles compared to this addition. But we are not going into the complexities that are related to the equivalent machine language code, because you all know that these are the high level language code. It get transferred to the machine language code, and then it is being executed. So we are not going into it. We are only we are only considering the analysis that are confined within the algorithmic steps that are being written. We are not considering the equivalent machine language code that will be generated out from the programs that is being developed from that corresponding algorithm. No, that there we are, that much details we are not going into it, because it is outside the scope of this particular subject. Okay, so if we are not considering the complexity of this machine learning code, then if you are then this particular statement, if you consider, this will take the constant unit of time. Because why this will take constant unit of time? So you see the multiplication is being done with a and b as the variable, with 5 is a with 5, so a is being multiplied with 5, and 3 is multiplied with b. Now for again, you consider 10 students are executing this particular uh, statement, algorithmic step. They are implementing this algorithmic step in their coding, and suppose those two students, as I said earlier, are using 10 PCs which are having the same configuration. Then as a whole, if you consider this statement as a whole, if you consider this statement, again this statement, if this 5 into 8, if this operation is taking, suppose say 2 millisecond of time, and 3 into b, this statement, this section is taking again suppose 1 millisecond of time, and this addition is again taking suppose 2 millisecond of time. So 2 plus 1 3, and 3 plus 2 5, that is 5. All in all, 5 millisecond of time will be required. If this 5 millisecond time will be required by a particular machine, and all the remaining 9 machines will also be taking or requiring 5 millisecond of time, because the configurations are considered to be as the fixed hardware configuration. So again we can say, and and if you change the value, if you change the value of a and b, then again the same this will never impact on this overall or cumulative time that is being required to execute this statement. That means the 5 millisecond of time. Okay, so this is again a constant time. So we can express the time taken to execute this particular statement, that is x equal to 5 into a plus 3 into b, will be again taking constant time. That means, and the constant time, as I told you earlier, is expressed as 1 unit of time. In this way we can express. And now coming to the, this is all about your time complexity, and we'll be dealing with examples also, so that to make this clear, concept clear. So let us also consider the space analysis of this algorithm swap. Now you see here how many variables we are using. We are using over, if you revisit this particular algorithm, how many variables we are using? We are using a, b, and this stem. That means total 3 variables we are using. So each of these variable we will be taking one word each. So each of these variable will be taking the one word each. So total Sn we generally represent the space function of our algorithm as Sn, where n is the input size of that algorithm, and the time function of the algorithm as Tn, where where uh, this uh, uh, n is considered to be as the input size of the algorithm. Okay, so over here Sn is actually the cumulatively, if you cumulatively, if you see, it is this Sn is expressed as a 3 word. Again, it's a constant word. So since these 3 variables, we do not know in the algorithmic steps how these 3 variables will be represented. Will these variables be represented in terms of integer, or will it be represented in terms of float? Okay, or it will be represented in terms of double. We do not know the data types by which it will be represented. That is why we generally use this one word. We write this as one word. So if it is represented in integer, then it will be one integer. One This a will be considered to be as an integer. Okay, and this will be and this is actually your constant, that is one word and one word. Total cumulatively we can express this Sn as Sn equal to 3 words. Okay, now this way we have calculated the Tn, the Tn and Sn of of the algorithm. Now we need to so while converting this algorithm into programs, we will be writing the equivalent codes, and both this Tn and Sn, so these are actually calculated, the functions we have now determined. Now they can be represented. I have told you that this Tn and Sn can be represented in terms of your lower bound, upper bound, or average bound, or tight bound, we can say, for that average bound. So that we can represent with the help of some notations. That is, we can say big O, or this is your big omega, or this is your big theta. Okay, in this way. So these are actually asymptotic notations, which we will discuss in details. For the time being, you just consider, since this Tn, is actually represented as 3, this Tn over here is equal to 3. That means 3, it's a constant unit. So we can represent this Tn, since it's a constant unit, big O or big theta O. We can say big O or big theta of 1. We can also write this as the big O of 1 or big omega of 1. Any of these three will have good, but better you write this thing, that is the tighter bound, that is the theta. In terms of theta, you can write big theta. No, theta of 1. And why 1? We are writing why 1 over here because this is a constant time. Tn equal to, it is taking a constant time, and so a constant is represented by 1. If you are representing this as a time and space function, or you are representing them as a lower and upper bound using the asymptotic notation. So a constant is represented as, generally is represented by 1. Similarly, Sn also over here, 3 word, that means again it's a constant word. Okay, so Sn is again, 1 minute. Sn, so Sn can be again represented in constant time, that is your big theta of your 1, or we can write big O of 1 or big omega of, any one of these thing will do good, but preferred thing is this one. So if while analyzing, you can first, I can say one thing. So you try to analyze the time and space function in terms of, first you try to analyze them in terms of tighter bound. That means in terms of the big theta. I will discuss in details each of these three your asymptotic notations. But for the time, you just remember this as a right hand thumb rule, that if you are having a tighter bound, you should always represent the time and space function with that tighter boundary by using the asymptotic notations. Okay. In case if you do not have any tighter bound, then you can go for either upper bound or you can go for lower bound. But as long as tighter bound exists, you use that tighter bound notation. That means big theta, small theta. You will also see small theta notations to represent the time function and the space function, which are commonly represented as Tn and Sn, where n is the size of the input for that algorithm. Okay. So from here we will be seeing these several examples, several type of examples, and we will try to solve this, compute the time and space function from this algorithmic snippets. So you see, this is one algorithm. This is one algorithm for what? It determines this algorithm is written to determine the sum of all the elements in an of an array. So the name of the algorithm is sum, and the two input parameters which this algorithm is accepting is a and n, where a is the list of elements and n is the total number of elements present in that particular list. So to start with, so begin block, and this is the end block. So within that, s is a variable, s is assigned the value 0. That means it will be calculating the sum, and you all know these things because you have already done this kind of programs in the previous semesters. For I is equal to I, taking the value from 1 to n, what we are doing, we are actually this s will be capital letter S. Okay, this S will be adding the value, adding the element which is present in the list A with itself. Initially, the value present in S is 0. So every time the content of S is being added with an element of the list A, and this process will continue as long as the total number of elements are there, are considered. Okay, so once all the elements, you traverse all the element, we come out of the loop, and then you return s. This s will give you the cumulative sum of all the elements which are present in the list. So let's start to analyze and to determine the time and space function. So this particular statement, s will assign the value 0. This is again a will be taking a constant unit of time. That means 1 unit of time it will be taking. Okay, then this loop, that means for I assigning value 1 to n. Okay, so here the this particular loop, so any loops, this particular for loop, so this loop will be executing for n plus 1 time, because it will be taking the condition. So one extra time it will be executing, but all the statements which are there within that loop, it will be taking n units of time. So n plus 1 time. Okay, this loop will be executing. S will assign the value s plus ai. That means it will be taking n unit of time, this particular statement. Okay, and once you come out of this loop after n plus 1 time, once you come out, this return is, this is again a constant time it will take. That means 1 unit of time. Now cumulatively add to determine tn. So tn in this case will be n plus 1 plus 1. That means n plus 2 plus n. That means 2n plus 2 plus 1, 2n plus 3. So tn will be equal to 2n plus 3. Okay, and Sn, that means S. Space analysis, how will you do this? A is the list, A is the list, and n is the variable size of the list. So A will be taking n, so A will be taking what? So A will be taking n what? Because A is the list of n elements. So A will be taking, this is n words. So I have listed over here. N will be taking one word. This S, S is a variable which is again taking the, which will again take the one word, and I, so that is the index variable which is used in the for loop, one word. So if you cumulatively add Sn, Sn will be equal to n plus 3. Sn will be equal to n plus 3. Okay, now we have discussed your Tn and Sn. Now we will represent the Tn and Sn in terms of asymptotic notation. That I will tell you in my second lecture class. So from up to here, I am concluding my first lecture over here. Now in the second, in my second lecture, I will start from here, and then I will tell you how we represent this. Once we actually determine the time function and space function, how we represent them in terms of asymptotic notation, that I will tell you in my next class. So I am concluding my lecture over here. Okay, thank you.